Okay, so we'll get started. My name is Yannis Paskalidis, and I'm a faculty on the Charles River campus in the College of Engineering and also in Computing and Data Sciences. And I'm the director of the Hariri Institute for Computing and Computational Science and Engineering, which is one of the organizers of the event today. The goals today, you can think of this as a speed dating session to learn about the funding opportunity, the specific funding opportunity that we have, to meet potential collaborators and also connect with them, form networks, and potentially collaborate in submitting a proposal. This is a call for a program or part of our focused research programs and focusing on population health data science. And we are very grateful to a number of different organizations on campus that are co-sponsoring this program with us. So I would like to thank the School of Public Health, Population Health Data Science Program, the Clinical and Translation Science Institute, and the Evans Center for Interdisciplinary Biomedical Research. So the opportunity is to submit a pre-proposal, and there is a deadline on February 16 coming up. This is a program that will be focused on health data science, broadly defined. We provide, if we fund an effort, we are going to provide full support from the Hariri Institute in terms of any grant submissions that may be coming up from the group that we fund. We'll essentially support them for a year, offer them the option of organizing a symposium, dealing with communications. The purpose is to essentially have a team work on a specific topic, coalesce around a topic, and so that this team in a few years is ready to go out and submit and be competitive for a federal award. The agenda today will start with some very brief remarks from a number of individuals, and I will introduce them as we go along. And then we'll have lightning presentations from faculty that we have invited. The list of faculty that we have invited is definitely not inclusive of all of the faculty that work in this area, but we wanted to highlight some of the interesting work taking place both on the Charles River campus and also on the medical campus, and also provide opportunities to people to meet one another. And then at the very end, we'll ask you to take lunch and mingle and connect. So for the faculty that are presenting, you will have 2 minutes, and Catherine will be making sure that you know that your 2-minute limit is coming up. The event is recorded, so those of you that could not make it today or other colleagues and collaborators you have, please direct them to the Hariri Institute YouTube channel. These are the faculty presentations that we have lined up, and I will be introducing them one by one. A little bit about the Hariri Institute and specifically this focused research program. We are looking to fund a team in this area of health data science, again, broadly defined. We're looking to fund a medium to large team that typically is led by 1 or 2 senior faculty, has maybe 2 to 3 thrusts. Each one of these thrusts should be led by some other faculty. Larger groups, I think, are something that we look for, particularly because we think that there is a little bit more of hand-holding and effort that needs to be put in place for such a larger group to come together. We think that smaller groups will sort of organically come together and collaborate, but it becomes a little bit harder with larger groups, and these are the type of efforts that we would like to fund. And we are looking for new collaborations, for new ideas, for bold ideas that have not been proposed to some federal agency already, and they have the potential for this group of faculty that comes together after a year or so of work to, as I said earlier, coalesce around an area and be more ready to go out and compete for a large center-like federal award. So with that, this is how you can get in touch with us. And I would like next to introduce Will Tomlinson. He is the director of the Software and Applications Innovation Lab at the Hariri Institute. And SAIL can be a partner in a possible effort. Will describe what they do and the capabilities that they have. And they already are collaborating with a number of different groups here on the medical campus. So Will.
Ooh, when you come up here, watch out. It's like a hump here. That far. Almost caught me. Good afternoon, everyone. Afternoon. Thank you, Giannis, for that introduction. As Giannis mentioned, my name is Will Tomlinson. I'm the director of SAIL, which stands for the Software and Application Innovation Lab here at Boston University, and we sit inside the Hariri Institute for Computing. In a nutshell, SAIL is a service center set up with professional software engineering staff, and our goal is to provide full-stack web and mobile application development support to help either instantiate the progress of research or drive the progress of research for all of you faculty members that are here at Boston University and even beyond. But our primary audience is here at BU. The role of SAIL is an ever-growing and ever-important topic to talk about when we talk about academia and the research projects that we help to contribute to, as the need for software engineering and research is rising, not just within the disciplines you all are focused in, but throughout the university, humanities, social sciences, et cetera. And the need for quality software and the work that your graduate students, undergraduate students, postdocs take on, SAIL plays a critical part in making sure that we can move that to the next level of production quality software. And as open source software becomes something that funding agencies like NIH and NSF heavily support or heavily champion for the act of, it's having a component like SAIL has been pretty useful for the university to leverage in that capacity. But overall, we have a professional staff of about 13 personnel, 9 engineers, 1 technical project manager, and 3 at the management level, including myself. And not only do we develop these products for research, but we also help to act as a context holder or sharer for work that you may already have. As the nature of students is pretty transient and cyclical, SAIL can be a resource that you all can leverage to maintain context as these students transition in and out of your lab if you want to continue to maintain a product for some longer period of time. And a part of what I offer here as a leadership of SAIL is the ability to help co-pursue extramural funding, not only for SAIL contribution, but for your own research goals. I always get scared to advertise that I can help write grants and other things to PIs because I usually shoot myself in the foot with that and I get an influx, but we're always happy to help in that department. And yeah, these are some of our example offerings and service areas relative to research. Read them at your leisure, but I think that is my time for you here today. Thank you.
All right, thank you, Will. So next, I would like to ask Debbie Cheng to come and talk a little bit about the Population Health Data Science Program, and also Laura White.
Thank you, Giannis. Hi, everybody. My name is Debbie Cheng. I'm professor of biostatistics at the School of Public Health, here along with
Laura White, also professor of biostatistics.
Together, Laura and I lead the Population Health Data Science Program. We are very excited to be co-sponsors of today's event because really the mission of our Population Health Data Science Program is to advance the development of health data science research. So funding opportunities like this FRP and fostering new collaborations through events like this, these are really key parts of our goals. We want to take just a minute to tell you a little bit about our program. For those of you who may not be aware, we launched last spring, less than a year ago. And the main goals of our program are to foster collaborations across the many different disciplines engaged in health data science, to provide training and education opportunities in health data science, and also to catalyze and support the development of novel data science work. Now Laura's going to tell you about some of the various activities that we've planned for this year.
Great, thanks, Debbie. We've been really excited over the past year to connect with a lot of you and other colleagues across medical campus and CRC. It's been really nice to see the enthusiasm for this work. We've had a lot of events over the past year and continue to have a lot of events through first our Health Data Science Distinguished Speaker Series. We have an event coming up next week, next Thursday, with Tamara Broderick from MIT coming, and then in March we'll have Jessica Holman from Northwestern speaking about data visualization. That will be followed by a workshop in data visualization on March 26th. So keep an eye out for those events. We also it will become a tradition now this fall. We'll have our second fall poster session. That's a great community building event. It's also a nice opportunity to showcase some of the work that's been done by folks that we've just recently funded through a seed funding opportunity. So they will be presenting as well as anybody else who has work they'd like to present. We've also been working with industry partners and been facilitating fellowship opportunities for students with Pfizer and Vertex, and working on building out some of those opportunities as well. So we're really excited today. This is an event we've been looking forward to. It's very in line with our mission of trying to just create and foster new collaborations and research innovation. So thanks.
Thank you. Next, I would like to ask Katya Ravid, who is the director of the Evans Center for Interdisciplinary Biomedical Research, to say a few words.
Thank you. Okay. Thank you all. I want to start by thanking the leadership of the Hariri Institute and those who have facilitated this event, Robin, Catherine, and others that I have not mentioned. So it's a beautiful event of bringing all of us together. I direct the Center for Interdisciplinary Biomedical Research, and our goal has been and continued to be linking research and researchers, but not the speed dating. More, we take our time to identify progressive, creative topics and bringing investigators representing different disciplines, and for which we have developed platforms to facilitate this type of research or approach to research. We call it Affinity Research Collaboratives, or ARCs. ARCs consist of investigators, as I said, representing different disciplines. We have funding for such ARCs. They can be in a variety of topics, and we are very pleased to co-sponsor this event that will focus on bringing together investigators searching in the general area of data science, which is really important and upcoming. I want to mention another platforms that we have recently developed that has to do with supporting an ARC that focuses more on technology development, and that could be in the area of chemistry, of software development, and other domains. And we have an inaugural one that we have just sponsored, and more will be shining more lights on it as it develops. And so, as I said, today we are really pleased to co-sponsor this event and to help in promoting data science as it applies to a variety of domains. And please feel free to contact me directly or Robin McDonald for logistic or content-wide questions. And enjoy the day and the presentations.
Thank you, Katya. So now we'll move to the lightning talks, and we'll start with Brian Cleary, who is a professor and assistant professor in computing and data sciences and also in biomedical engineering and biology.
Oh, no. Do you want me to find where I am here? Where's the mouse? I'll just do this. Apologies. Sorry, I don't know where the cursor is, so we have to do it this way. Did we pass me?
Yes.
Oh, my God. Oh, yeah, here we go. Okay. Thank Thanks for the introduction. Sorry for the misscroll there. So very quickly, I'm going to talk about sort of one branch of the work that we do in our lab that is this thing over on the right. We also do a lot of over on the left. This sort of grayed out thing is developing new methods and new technologies to kind of characterize patterns in cellular and tissue systems. We do a lot of single cell RNA sequencing and spatial transcriptomics. But the two projects I'm going to talk about today are, rather than sort of characterizing what patterns exist, like what genes are co-regulated or what perturbations tend to result in similar outcomes. Today, I'm going to talk about a couple projects that have more directly focused on this question of why certain patterns exist and more of a theoretical approach to understanding organization at the level of cells and tissues. And in particular, the two projects that I'm going to briefly introduce today come from a very particular ideological perspective. I'm very interested in the idea of kind of flipping the normal directionality of genetic and molecular features determine sort of physiological traits on its head. And these two projects are directly interrogating how physiology determines molecular and genetic features like selection. So the first project here is focused on experiments aimed at profiling transcriptional kinetics. So we and others have done experiments that do so-called RNA velocity experiments at the level of single cells that essentially profile both pre-mRNA and mRNA for every gene in every cell and try and infer from that kinetic parameters, production rates, and degradation rates of individual genes. And from there, you can do all sorts of stuff, like try and infer trajectories of single cells. But what the normal methods, including things that we've done in the past, can't do is take account of global constraints. And as I said, this is sort of what I'm very interested in, is how sort of the physiological state of the cell determines gene expression regulation, or in this case, the velocity of individual genes, okay? So rather than trying to interrogate gene-specific factors of what is causing one specific gene to be produced at a certain rate or to be degraded at a certain rate and affecting its overall velocity, we're interested in how a global physiologically determined constraint on the cell is dictating a balance between the RNA velocity of different genes or different RNA compartments in the cell. And as kind of shown over there on the figure on the right, in particular, what we think, we have a quantitative framework for this, and we're now sort of pursuing experimental investigations of this basic idea, is that a particular aspect of the metabolic state of a cell, in particular, the balance of flux through different processes that either produce NTPs or consume NTPs, determines what we think of as the total velocity of a cell, which seems like it should be sort of a foundational concept, like how quickly can the cell change its transcriptional state, which again should set a lot of sort of fundamental properties, like how quickly can that cell differentiate, or how strong of a response can it mount to an environmental stimulus. So again, I'm very interested in this idea that the physiological state of the cell is actually setting how quickly we can transcribe genes globally across a cell. And what comes with that is if I want to upregulate some genes, I need to downregulate some other genes. Okay, and the second project, again, from this idea of physiology determining molecular, or in this case, genetic outcomes, I will just quickly summarize to say sort of the ideological prior that we're coming from here is that genes are not natural objects of selection. They give a very weird view of evolutionary processes, despite the fact that they occupy 100% of the interrogation that we do, and that more natural objects of selection comprise units of collective activity. So that selection can be viewed as acting collectively on many different processes simultaneously. So I'm out of time, I'll stop there, but happy to talk more later if anyone's interested. Thanks.
Thank you, Brian. So next, I'd like to ask Heather Su, Assistant Professor of Pediatrics in the School of Medicine here.
All right, so I'm going to talk about value-based care and payment, which has really been a defining feature of the U.S. healthcare reform landscape over the past couple of decades. So at its core, value-based care aims to improve value by linking payments to measures of quality. There are two main levers for improving value. You can either increase quality or decrease spending. The programs tend to offer bonus payments for better performance and financial penalties for poor performance. So because of this, measurement is really a cornerstone of value-based care. And when I say measurement here, what I mean is kind of the business of accounting for things that we think matter when it comes to health and healthcare. So that would be quality measures, costs, or patient characteristics. Historically, safety net healthcare providers have fared really poorly under value-based care contracts. But despite this, value-based care is often held up as a potential mechanism to improve health equity through implementation of financial incentives for healthcare providers to address adverse social conditions associated with poor health. This has been a very popular subject of commentaries and a great hope, but very few of these programs exist kind of in the wild, and the effectiveness of the approach is really unknown. So here in Massachusetts, we have a pretty unique opportunity to develop the evidence base in this area. In 2018, our state's Medicaid program, which is called Mass Health, embarked on an ambitious value-based care transformation, adopting an accountable care organization or ACO model of care. So in an ACO, healthcare providers are paid a lump sum for each beneficiary they cover. These payments commonly use risk adjustment to allocate more money for medically complex ACO members. So for example, someone with diabetes or hypertension would have a higher payment associated with them than someone without. But they typically did not pay more for complexity related to social factors. However, in Massachusetts, when we switched to an ACO model of care, Mass Health adopted an innovative new approach to setting payments that accounts not only for medical complexity, but also for social complexity. In particular, housing status, as well as neighborhood level exposures. So this new approach is really specifically designed to pay more for ACO members that are anticipated to have structural barriers to achieving optimal health. So my research agenda focuses on using this Mass Health value-based care transformation as a natural experiment to assess the effect of value-based care reform on quality of care and adequacy of payment for the healthcare safety net. My overall goal in pursuing the line of work is to address potential issues of measurement bias in accounting for social factors in value-based care, as well as to identify opportunities for payment model improvement. In order to accomplish this, I've been cultivating a new population health data resource at BMC, which links our BMC electronic health records, the electronic health records of community health centers, to BMC's WellSense plan medical claims data, which currently represents about 560,000 patients here in Massachusetts, at about 40% of all Medicaid beneficiaries here in the state. So my goal for the new data resource is to ultimately to be available to BU and BMC researchers who are seeking to conduct policy relevant research and to evaluate the effectiveness and efficiency of BMC's many innovative programs to try to address improvements in care for structurally marginalized people.
Thank you, Heather. So next, Marc LaRochelle is an associate professor in the Department of Medicine.
Hey, everyone, thanks for the opportunity. So I'm a primary care clinician who does addiction and health services research, and I apologize, I can't stay for the speed dating portion because I actually have to go see patients, but please reach out if people want to talk about anything. So I'm going to share a structure of an ongoing project that we have here that's an R01 funded by NIDA to do comparative effectiveness emulated trials for medications for opioid use disorder. And really, what I want to talk about is target trial emulation as a framework for doing observational comparative effectiveness studies. For MOUD in particular, we're having increasing number of formulations and how they're being delivered, but active comparator studies are really uncommon. RCTs are very expensive and take time. And the other thing in the opioid space is that the public health outcomes of interest, particularly overdose, while a big concern, are relatively rare and very hard to study in RCTs with adequate power. So observational studies are one way to go, but RCTs and observational studies often don't agree, and they're often very far apart. And then it raises the question about whether or not observational data are valid. There's clearly selection differences. RCT populations are generally more restrictive. One thing we focus a lot in the addiction space is RCTs involve incentives for study participants, and we actually call this an intervention for people with addiction. It's contingency management when you reward behaviors like coming to appointments. And that itself may be part of the intervention that's happening as part of an RCT. And then in observational studies, of course, residual confounding from lack of proper randomization. So this emulated trial framework is, can we use observational data and really set up a better study design and framework to make studies more comparable? And so this analogy I like to use is an RCT. You know, you might think of like the apple that everyone thinks about in the fruit world that you give to your teacher and everyone recognizes and sees as really being a gold standard of fruit, right? And I think observational studies are kind of like the durian of the evidence pyramid, right? Very controversial, may even be banned from places. No one wants to see them. Debbie hates observational data because you can't randomize. But the question is, can we do better with what we're doing? And actually, Sarah Lodi is faculty over at BU and is part of this project. And she had developed an approach to where you can actually benchmark your observational data against RCTs by harmonizing the protocols so that you're trying to answer the same question, use as close as possible the same population and the same analysis. And you're not going to get down to the same thing, but maybe you can get something that looks a little closer to each other than what you had before. And so these are some preliminary data that we have from this study so far. And the top here is what I think of as the red apple and the durian. The XBOT RCT was an RCT done of people in detox. It was about 500 people comparing two drugs, buprenorphine and naltrexone. And they published 24-week completion rates, which you could think of as retention. They were very similar, but actually naltrexone was a little bit higher. It was 4% higher than buprenorphine in the RCT. But in observational data, this was one done by faculty here at BU, Jake Morgan, found very different results. Only 30% retained at 6 months for buprenorphine and only 10% retained for naltrexone. So it looked like buprenorphine was favored by 20%. So very different result than what you see in the RCT. So we went through this process of harmonizing study protocols. We have this huge data set in Massachusetts that's linked at the state level. And compared that to a reanalysis of XBOT, and we got a lot closer. At least directionality was the same. We saw overall higher rates of retention in the RCT, but an absolute difference that was similar. So this is an approach we're increasingly thinking about using to try and answer questions. I focus mostly in the addiction space, but could really be used anywhere.
Thank you. So we'll not take questions because people will stay, but because Marc has to go, if there is one question for Marc, we'll be happy to take it. Okay. So, all right, so then we'll continue. Ben Linas was supposed to be here, and he apologizes. He cannot be here because of a family emergency that happened today. So since we have the slides, I'll play the role of Ben Linas for 1 minute, and I'll just skim through the slides. So his group works in HIV, hepatitis C, and substance use disorders. All of these things are obviously correlated and connected, so they call it syndemic, and they develop data analytics and simulation modeling solutions for these types of applications. They have access to large data sets that are listed here, and some of the work that they have done, so some highlights of the work. So they have worked on, for instance, on mortality models and understanding the effect of community level interventions. And you will see a number of other papers that are listed on this slide. And of course, I cannot answer any questions, so any questions can be directed to Ben that you can reach through email. All right, so next we'll have Jonathan J., who is an assistant professor in community health sciences at the School of Public Health.
Hi, everyone. So firearm injuries are a major population health issue. They're now the leading cause of death among children and teens in the US. Most of those deaths and injuries come from assaults, and not from the ones that you see on the news, mass shootings and school shootings, but rather everyday conflicts. We have seen that this problem got even worse during the pandemic. And it is this is a health outcome that shows some of the most extreme racial and ethnic health disparities that we see for any health outcome. For many of the most severe health disparities, we're looking at sort of 2-to-1, 3-to-1 ratios in bad outcomes across racial groups. For firearm injuries, we see differences like 40-to-1. And in this study from the right, 100-to-1 in child gun assaults between Black youth and white youth in major cities during the pandemic. So those kinds of profound disparities can only be explained by differences in the social, physical environment and these sort of higher structural levels. So some of my work is focused on the link between long-term physical disinvestment and the physical environment in neighborhoods where kids grow up. So I didn't have time to show this, but we have a lot of evidence that there is that intervening on the built environment to make spaces greener and feel safer is associated with reductions in gun violence in RCT settings. So in this study that I'm showing, we are trying to develop a measure of long-term racialized neighborhood disinvestment. Some of you may be familiar with redlining, historical redlining in the US. This was a government-sponsored process that favored majority white neighborhoods starting in the 1930s with mortgage backing and systematically disinvested from neighborhoods with more Black and other residents of color. So what we did was, for the city of Philadelphia, we assigned the actual redlining grade for each 500-meter square. And we wanted to train an algorithm to predict what was the original redlining score based on how that area looks today in aerial imagery, in high-resolution aerial imagery. So are we able to pick up the signs today of that long-term disinvestment from the 1930s? And so we use a pre-trained convolutional neural network. As some of you may know, this is not the most advanced, complicated process, but these are algorithms designed to take an image in and output a prediction about sort of what is in this picture, whether it's an apple or a durian or something else. We extracted mid-level features and used those to train a penalized regression model. And what you see is that, well, what you may be able to see on the screen is that the algorithm gets quite good at predicting which areas had gotten a more favorable score and which ones got a more adverse score, because an A was the best score that a neighborhood could be assigned in the 1930s, a D was the worst score. And these are some representative images from each of those predictions today. So you see that we're able to see that the redlined, on average, the redlined neighborhoods from the 1930s today contain much more pavement, much less green space. And we can see how these are environments that are more conducive to gun violence. And we're sort of developing this as a measure. And we find that it does have predictive validity around neighborhood gun violence today. Thanks.
Thank you. So next we'll have Nathan Fillmore, who is the director of the Boston Informatics Group at the Boston VA.
Hello. Yes, thanks for having me. I'm Nate Fillmore, so I have a group at the VA as well as BU and a few of the other local institutions sort of spread around, and we are working towards building a quote unquote learning healthcare system at the VA. But with some of my collaborations with Dr. Ravid, Dr. Camille Edwards at BU, we've also been expanding to some really cool stuff at BMC as well. The idea of a learning healthcare system is to try to align incentives to leverage the fact that now the practice of medicine is so mediated through all the electronic digital capture systems to better integrate the process of delivering care and the process of doing research, and so that we can continually learn from the care that's being provided and also continually deliver the knowledge that we're generating in more of an immediate term, as opposed to, in addition to publishing papers and hoping that eventually people read those papers and incorporate it into their care eventually. And we've been attacking both of those two things separately. So first, in terms of trying to be able to efficiently generate knowledge using all of these digitally captured data, we have a whole bunch of different projects, primarily in cancer. For example, work that we've been doing with Dr. Ravid, Dr. Chitalia, and others at BMC is we developed a risk prediction model for cancer-associated thrombosis using data from the VA, and we've now validated this in a couple of institutions, including work in progress, nearly completed at BMC. And similarly, we've done work in multiple myeloma, generating real-world evidence to understand the impact, the relative effectiveness of different treatments in patients in the real world who, for example, at the VA have a high degree of frailty and multimorbidity. This uses some of the trial emulation techniques that was discussed by one of the previous speakers. And then we use AI methods to develop a passive cancer pre-screening algorithm to identify patients who are at high risk of developing pancreatic cancer. So those are just a few of the different things, but sort of programmatically what the group is trying to do is to develop infrastructure to do these projects super efficiently and with very high quality, using all of these resources that we have available. And then we're publishing papers, as I mentioned, but programmatically the goal is to not just publish papers, but also to deliver those to the clinic in the near term using some software development, like sounds like that's happening at BMC as well. So we have a suite of software applications that we've developed and deployed nationally at the VA for clinical trial matching, where we can efficiently match patients to trials using data from the electronic health record. We developed, with some of the geriatric oncology work, we developed the real world evidence, as I showed on the previous slide, and now we're delivering this to clinicians and piloting use of this at a couple of sites around the country. For the screening thing, we've developed in lung cancer is where the app is, but we sort of, like with the pancreatic cancer thing, we developed a model, and then the next step would be to try to figure out how to deliver that so that people can actually do screening. And so we built an app like this for lung cancer. And then we have a tumor board application that mediates conversations that are happening in tumor boards. And then the cool thing about this is that we're capturing these conversations that happen like in a distributed way with some of these national telehealth stuff at the VA, but then we can also add in other things like our risk prediction models. We can add in there as another person in the room in the tumor board, and we're working on that as well. So those are just a few of the specific initiatives that we're doing, but I'm super excited to meet a lot of you and work together potentially. Thanks.
Thank you, Nate. So next we'll have Wendy Kuohung, who is Associate Professor of OBGYN.
So I'd like to thank Debbie and the event organizers for allowing me to share some of our research interests. And I have to comment that this is just a great variety of different projects and different specialties that's been assembled. So that's really awesome. So originally I wanted to talk about ectopic pregnancy and ovarian torsion, but given the 2 to 4 minute limit, I'm only going to be able to talk about one thing. So I wanted to talk about ovarian adnexal torsion, which is one of the top challenging diagnoses in OBGYN. And it's the fifth most common surgical emergency after ectopic pregnancy, hemorrhagic ovarian cyst, pelvic inflammatory disease, and appendicitis. And misdiagnosis of ovarian adnexal torsion leads to loss of organ function and frequently litigation. The accuracy of diagnosing ovarian torsion is roughly 44 to 60%. So it's about like a coin toss. So we definitely need better methods of diagnosing this GYN emergency. And the primary risk factor is ovarian enlargement due to a mass, and torsion is more likely to occur when the ovary size is over 5 centimeters. However, even with that kind of like simple metric, there's a very wide variability in management. Patient characteristics can be impacted by older age, higher parity, meaning number of children had, the affected ovary size, the route of surgery, even the GYN surgeon subspecialty that impacted the likelihood of doing surgery and also taking out the ovary. And just as a general aside, women's health is an understudied area in general, and in artificial intelligence in particular. If you pull up like data science, machine learning, and ovarian adnexal torsion, you get a grand total of 4 papers. So this graphic is just to really quickly show that what we face in the clinical world, that you have 2 patients. The patient to your left is a patient that I did surgery on like a while back, and then the patient to the right is the patient that I did surgery on this month. Substantially similar age, complaints, nausea and vomiting. Ultrasounds are roughly similar. One had torsion, one did not have torsion. So the problem is that the diagnosis is made clinically, and clinically meaning that based on symptoms and findings, but these can be non-specific because they're very similar to what other conditions that may present with pelvic pain, adnexal mass, nausea and vomiting. Ultrasound may show an enlarged ovary, but presence of Doppler flow and ultrasound does not rule out torsion, as it does in testicular torsion in men. So, and the few AI studies that there are on this topic have really only scratched the surface. They've looked at kind of laterality of torsion, ovarian volumes, Doppler signal, visualization of peripheral follicles, presence of the mass or cyst, free fluid or neutrophil to lymphocyte ratio. There are no studies looking at kind of like what type of mass it is, whether it's a dermoid, which is lighter because of fat and hair content, versus an endometrioma, which is heavier and more likely to have surrounding adhesions. No one's really looked at kind of the role of age, because that can affect uterovarian laxity, and presence of previous surgery, things like that. So I think that I'm hoping that there would be some interested parties to show, and we could work together on making an algorithm to improve the diagnosis, preoperative diagnosis of ovarian torsion.
Thank you. Next, Archana Venkataraman, who's an associate professor in electrical and computer engineering.
Thank you, Giannis and Debbie, for inviting me to speak, and a big thank you to the organizers, especially Catherine and the rest of the staff, for putting on a fabulous event. So in this talk, I'm going to sort of give you an overview of my research in our lab, and then highlight one specific project. So effectively, my lab and our research is at the center or the intersection of 3 pillars. So the first is biomedical signal and imaging data. Primarily, we look at neuroimaging data, but we've also worked with genomics, behavioral data, and electrophysiology. The second is data analysis or data science methods, including artificial intelligence, machine learning, statistics, and optimization. And the third is clinical neuroscience. And so effectively, my lab is developing new computational models and algorithms to really harness the information in these biomedical data sets and say something about brain dysfunction. So that's a really broad characterization. And we work on really a spectrum of open projects and problems, starting with more foundational methods to address basic computational neuroscience questions and develop frameworks that can be broadly applied across studies, to translational applications of neuroimaging and electrophysiology data, to more exploratory methods for understanding cognition and probing the brain-body interaction. Now, across all of these projects and sort of this entire spectrum, we're faced with many challenges. So we have very small data sets, and that's due to just the difficulty in acquiring data as well as the cost. There's extreme patient heterogeneity, which complicates the phenomenon that we're trying to learn that might be predictive. There's also a need for interpretability, and oftentimes that interpretability is more important than absolute performance. And finally, we have weakly supervised data. So there's a lot of noise in our problem. Some data sets can have missing data or inconsistent labeling. So my lab tackles these challenges by developing new modeling strategies. So one strategy we've used is to formulate deep generative hybrids. So here, the classical or generative component of our model can capture a priori insight about the data, while the deep learning module can really parse this really nonlinear and complex information. Another is to embed biological and clinical hypotheses about either the data or the phenomenon of interest directly into our model architectures. And finally, we've developed new training and optimization strategies to learn in the case of weak labels or missing data. So one project that I'd like to highlight, it's one of our translational projects. It's in, and the overall goal of this is to localize the source of epileptic seizures in the brain. And the particular modality we're using is called resting state fMRI. So this is sort of passively acquired MRI data. It can very easily be tacked on to a standard MRI preoperative evaluation for a particular patient. So it's very easy to fold into the clinical workflow. And then my student, so this is Naresh on the slide, and our collaborators at the University of Wisconsin. So we developed a sort of a deep learning architecture that'll actually parse the information in this resting state fMRI data set using information from neural pathways in the brain through these graph convolutions. And we also have two key insights that we're folding in. Sort of one is contralaterality. So we expect these seizure onsets to be lateralized in the brain. And the second is to mitigate environmental confounds by learning a subject-specific bias. And so with all of that folded into the framework, we've evaluated the model on a study of 14 pediatric epilepsy patients at the University of Wisconsin. And our framework, which is called DeepEZ, which is in the box, actually can predict in new patients the seizure onset. And so that was determined clinically by surgical resection. And this does much, much better than not accounting for these interactions or even other methods that have been proposed. So thank you.
Thank you, Archana. And last but not least, Zhang, who is a distinguished professor in the College of Engineering.
Good afternoon. Thanks, Yanis, for inviting me to here. I'm actually an experimental hardware person. But today I'd like to talk about how we can incorporating deep learning technology with medical imaging, primarily focus on MRI, magnetic resonance imaging. The reason I'm interested in is that over the past years, I've been making major progress improving the performance of MRI, mainly from the hardware end. However, we have to try every possible things. And then AI technology is becoming available. So in recent years, we make progress also focusing on AI-powered medical imaging, collecting data sets, dealing with medical different types of medical imaging types, performing model design, task design, training process, among many others. So generally, we are broadly interested in any possible technologies related to MR tags, imaging reconstructions, imaging segmentations, image-based disease detections, and classification. And then here's three concrete examples based on three recent publications. And to have a taste of AI insertion with MRI, we first focus on MR reconstructions for fast MR scanning. And then we propose two methods. And the first one is generally call it due domain CN method. So this is a more traditional method, mainly with the whole model being trained and being tested in a large open source domain, and then with various type of MR acceleration. Even this is more traditional, however, in close collaboration with Boston medical radiologist, we still make a significant progress and make it a superb performance. And the second one is more novel, interesting, which is diffusion-based model. Briefly speaking, allow you to do this MRI analysis in a frequency domain without worry about the Gaussian noise, providing a new interesting paradigms for future MR reconstruction. And we're interested in every aspect of MR-related technology, not limited by MR reconstruction. For example, we know that under different magnetic field, you have a different image qualities. The lower magnetic field, the poorer the qualities, because it provides a lot of background noise. So for us, we propose a method, so-called RNST, which is a deep learning based framework for MR magnetic strength transformation with very limited data. And we demonstrate successful transformation by using 1.5T and 3.0 Ts, and then we demonstrate its efficiencies. So currently we're working on a general model with medical imaging. We all know general model is becoming how popular in a general language, the text-based imagings. And we deeply believe this is also good opportunity for us to do cross-modality text. So we're currently doing, for example, framework design, prompt encoder design, and many more. We're doing tests for AI-enabled methods in more clinically relevant applications such as image reconstruction, denoising, deblurring, classification, and labeling, and also disease detection such as strokes. And thanks for the opportunity, and we can talk further.
All right, thank you. So let's give a round of applause for all of the speakers. And if there are any questions for any of the speakers, now is the time.
I have a question for Hi, the first speakers. I miss your first few minutes, the health data, population data database. Do you have access to the UK Biobank or which kind of databases you have access to? Or like UK? No, the two ladies that talk about population. Yes, I'm sorry, I came late, so I missed the beginning of your talk, but which kind of health databases you have available, like where I'm interested in UK, for example, in the UK database or the UK Biobank or the 1 million veterans in the US, or I don't know.
Yeah, our program doesn't really oversee or manage any databases, but we could help facilitate connections between you and others that do. So happy to talk
That'd be
with you more
great,
about that.
because to get access to those, we have to pay a lot of money. So if there is any BMC or BU based availability, it would be great. Thank you.
Heather, do you want to talk a little bit about TriNetX or?
Sure. Yeah. So at Boston Medical Center, we have access to a national database called TriNetX, which uses a common data model to combine electronic health records across multiple institutions. And so happy to talk to you about access to that. The other thing that you can do is on the CTSI webpage, there there's a sub page that has some different domains of data access, and you can click on the Trinetics link and get initial access to kind of play around without downloading any data, but in order to do kind of prep to research counts.
All right. Any other questions for anyone else? Our speakers. Katya?
Actually, it's more of a comment. It seems that there is quite a bit of interest in digital imaging and in application of AI. We have here Wen Lu, who is actually now heading a technology-driven ARCs. And as I bring this comment to encourage to see if there are just common projects that one can, or share technologies that one can start really developing based on what we have heard today, whether it is for the kidney in your case, or women health related challenges. So I would encourage, finding those connections, at least in this topic, if not others.
Well, do you want to just say a few words about your work and the type of images that you have access to?
Thank you. As Katya mentioned, so my name is Wen Lu. I'm one of the director of this first inaugural BU called Bit Art, and it's a new initiative try to develop a tool to help in different areas. So for us, we mainly focus on the kidney disease, and since I'm from nephrology here in the Department of Medicine, so we collaborating with different disciplines, the faculty in different area. For example, in pathology and also data science core here at the medical campus, and the computational biomedicine, as well as cell lab, and Will and Tomlinson just presented this. So we hope we can develop some tool and digital, we call digital pathology, and which can be implement and in clinical diagnosis as well as drug development. Thank you. So if you have any question, please feel free, we can discuss. Thank you.
Thank you. Any other questions or even comments? Anyone who would like to say a few things about what they're doing and their interests? Okay, so just to remind you, there is this proposal focused research program called the dates are here, a pre-proposal on February 16. Full proposals will be due. You will get some feedback from us, and full proposals will be due on March 8. In the meantime, feel free to contact me or Catherine, and we'll be happy to answer any questions you may have about the program. I would like to thank everyone for the presentations today. It was a fantastic lineup. Debbie? So yeah, the information is on the Hariri Institute website, and if you cannot find it, please get in touch with us. The pre-proposal is sort of a fairly short document. It's a web form that you have to fill about the team and the topic and the interest. And then the full proposal is a bit longer document, but not at the level of an NIH R01 or an NSF proposal. All right. And also let me thank Catherine, Jen and Ken, and also Robin for all of the work in putting together such a great event today. Thank you. So you are welcome to grab lunch and stick around, talk to people, and we'll be here as well. Thank you so much.